All right, we are live. Sweet. All right, cool. So let's see what we got here today. Oh, shit. Why does it make my stream private? What the heck? All right, there we go. I think we're all set up now. So let's see what we got. Minimalism in programming language design. Actually, that's kind of cool. Let's see what we got here. Before you go, this guy wrote a blog post titled Minimalism in Programming. Good idea to minimize complexity in programming projects. Yep, I agree. Okay, sure. Most modern programming languages adopt more of a maximalist approach. Adding new features. Yeah, this is kind of a problem because then you have to maintain it. Whatever you create, you have to maintain. And so new features kind of end up bloating your programming language and then not providing a lot of like heuristics or like what the best way to use something is. It's like imagine if you know the go-to function that no one ever uses. Basically, imagine like having 50,000 of those in C++ and different variations of it where no one actually uses it, but you have to maintain it. I think that's kind of the pitfall. Let's see. Intentionally designing a programming language to have fewer features and to change less rapidly over time is a powerful feature. I agree. When a programming language changes, it causes breakage and churn. Correct. Tools become out of date, but yeah, that's fine. Yeah. So he hasn't said anything too profound right now. I want to use C++ 20 modules in a new project, only to find support in G++ and Clang was so incomplete that modules were not a viable feature. Interesting. The language had become so complex and so many features had been added that compiler developers were burnt out. Yeah, that's true. I'm not sure what other language features he's talking about in C++ that he's talking about, but yeah, like I think the go-to function is a great example. And there's also the functors, which are the function pointers that no one really uses, but they are useful nonetheless. So C++ is very hard to parse. Yep. If you add on top of that the problem that the grammar changes will become even more complex every year. Yeah, so it's like exponential increasing complexity. One of the main weaknesses of Rust is the high complexity, syntactic and semantic, yes. I've tried learning Rust myself, could not fucking do it. Because I wasn't like actively using it, and I think one of the best ways to learn a programming language is just really to use it. That's it. It feels like the Rust compiler is always telling me that I'm too stupid. Yeah, that's funny. Yeah, designing it to be minimal and simple. Yeah, I think the simplest, in anything, the simplest ideas will always win in the long run. Provided they're correct, of course, right? Minimizing complexity is a great way to reduce cognitive load. Yep. We're also clever monkeys that can talk. Ha. Yeah, it's almost like making things as simple as possible is a universal concept. Who knew? Language complexity and how intuitive it feels is going to affect and attract and retain new users. Correct. Python walrus operator. What? What the? Oh. I have never used this operator. What the heck is this? It's called an assignment expression. Okay. But you already have an equal sign, so why do you need this? Benevolent dictator for life was a very contentious Python enhancement proposal where after I'd accepted it, people went to social media like Twitter and said some things that really hurt me personally. Oof. Yeah, I mean, this kind of speaks to how tribal we are when it comes to things in general. So this is like interesting. Okay, name equals expression. Name. Okay, yeah. So you have an expression here with assignment, and x is assigned with 2021 and returns 2021. Okay, I see. Why would we even use this? That's my question. Limit number, reduce number of lines. That I don't know. This seems a little sus. Because it's a very simple return function, right? Just store in a variable and go. Okay. Yeah. Okay. I see. So instead of like saying size, if yeah, you just have to don't repeat yourself with like some frivolous code, but like in general the fact that a function should in general be simple should make this like not a thing. Like anyway, like it doesn't really matter. I think it's just so trivial that is not really important. It's not like something that a developer like fucking breaks their mind, like breaks their code over either. So I mean, I understand why people like have issue with it, and I don't agree it should be in just from that perspective. But yeah, I don't know. It's more like a shortcut that for it's like more like a shortcut and boilerplate code for beginners. That's at least my take on it. So anyway, let's go ahead and bring my client on and let's see what's up. Hello?
Oh,
Hey, hello?
hello?
Yeah, I can hear you. Can you hear me?
Yeah, I can hear you. Yeah, I can hear you. Yeah.
Cool. Yeah, you're a little bit soft on my side, by the way.
Okay. Let me just. Hello, is this better?
Let me crank you up. Okay, hello?
Hello. Yeah,
Yeah,
yeah.
I
I
can hear
can
you
hear you
now.
fine.
Yeah, you
Okay.
were loud. I mean, you were soft, so I had to crank you up a lot. So,
Okay. Yeah. Sorry. I think. Yeah. I don't know. I think I set my volume to a little bit higher. I don't know if it
that's
helps
fine.
that much though.
All right, cool. Yeah. So I know we talked a little bit on it's called Friday and Sunday about your practice and your practice diary. Seems like it's gotten a lot better. How did you feel doing the problems for today? And yeah, catch up on
Uh.
everything.
Yeah. Okay. So problems for today. Basically. So well, yesterday was where the majority of my questions were solved. Today was a really sluggish day. I was kind of busy with work and stuff.
Uh-huh.
So I only got like around 4 questions done. Um, but yeah, so what the general idea. So I was basically going through the graph questions. For me, when I did the graph questions, I felt like I can write the high level description just fine. I understand the problem. I can write the high level description just fine. But when I go to actually implementing the idea, it becomes a little hazy, foggy,
Mm-hmm.
and like I end up tripping over myself a lot and maybe like make some typos that I don't catch right away that ends up me debugging for a while.
Okay. Yeah, perfect. That's a good example. That's a good description of this type of things you're struggling with. So yeah, let's take a look at that actually. So let me bring your uh, diary up. Hold up.
Yeah, sure.
Shit. J practice diary. Here we go. Cool. Busy with let me make a note of this, and then you have trouble translating idea to code. Okay, so give me an example of a problem, and do you have like a sheet for it?
Okay. You mean the practice sheet, right? Like where I actually solved the problem?
Yeah, do you have it like typed up or something?
Yeah, in that sense, I kind of forgot about that. So I wrote it in I have the text, but it's not in a Google Doc.
Okay,
So
because I want to see
uh,
like
yeah.
the steps in between. And by the way, did you do the runtime for these as well?
I had it in my head. I just forgot to say it. It was basically just like the typical, graph problems. Like I thought of it at first. It's basically just a typical, O v plus e thing.
Okay,
Cardinality v plus
in the
cardinality.
future, write down the runtime in the
Yeah.
runtime correct column.
Yeah. Okay. Yeah. The problems I recorded myself doing were paint a Boolean matrix, row 31, and row 36, which is transform one string to another.
Okay, let me read the diary entry and let me see if I can catch
Yeah,
something.
for sure. Yeah.
Okay, so you waste a lot of time trying to explain the same thing, repeating yourself, like how you consider different approaches to the problem. There's pseudocode, sure. Added visit set pseudocode while testing. Okay. Wrote X and Y not in visit, which caused error in the code. Should be current.
Yeah, so that was a typo that I didn't catch until like really later on, like 10 minutes. Well, I didn't really catch it in the end, but I worked around the problem. Like I basically just wrote another if condition that took it away. That took away the need for XY not invisited.
Okay.
Let me write down the pseudocode. So let me paste the pseudocode actually, so it'll be a lot easier for you to understand.
Sure. Right now this looks like there's two things. First one is that your naming convention sucks, but the question is why does your naming convention suck? It's probably because you had trouble, like you said, you had trouble translating between your ideas and what that looks like.
Yeah.
So to me, it boils down to like you not having the right idea of linking the code to your idea. That's it. At least on the surface level. And so that's what basically caused the typo. Or no, but what else? What other problems do you feel like you struggle with? Because I think we're let's review this video afterwards. But I'm gonna look at what are the other things you did.
So repeat the question again. What other stuff I felt like struggled with? Yeah. Other than like implementing the code into ideas, I felt it was pretty much okay. Explaining them in a sense, like without repeating myself like multiple times to like was also a problem because I know like initially when I'm not confident in my idea, so I repeat it multiple times to the interviewer until I feel like I'm more confident into it and saying it and all that. So I end up wasting a lot of time when I can just like say it once and then move on to the next idea. So that's a lot of wasted time there.
Okay, I see what happens. I know what's going on. So that one. So there's a thing in psychology where the more we repeat something, the more we believe it, and you're basically just doing that. But that doesn't necessarily change the validity of what you're doing. That's actually the problem. Is that you have this fake confidence essentially. And so the way you need to generate that confidence is by bulletproofing your idea. So you need to have the idea, make it clear, understand how what it's going to do, and then be confident in it by testing it.
Yeah.
So the difference, the reason why you're repeating yourself is because you're not convinced. So you're taking the wrong route here. You need to be able to test. You need to first understand the code, or at least understand the idea, and understand how to test it. That's how you build the confidence, not repeating your idea.
Yeah, I need to put more testing. Yeah. It's also really difficult, at least in my opinion, because I don't know. I'm not sure how to test exactly a good way to test like matrix questions or graph transform graphs because I can't really draw a circle on the IDE sort of thing. So it's a bit.
It doesn't matter. Like it's still very easy. Like if I look at this, let's look at your pseudocode, right? So the idea here let's bring up the problem statement just to make sure we got everything. So this one is row 31, which is what the heck is it? I need
paint a Boolean matrix 18. I'm not sure. It's in the graph section. Just a second question.
Okay, so let me open up the EPI. Give me a sec. Cool. Okay, so this is paint a Boolean matrix. All right, 357.
Yeah, I felt like paint was a really weird wording for it, but I think it's okay.
Okay, so paint a Boolean. Let's see exactly what we need to do here. Let A be a Boolean 2D array encoded black and white image. Entry can be viewed as an encoding in the color entry AB. Sure. Call two entries adjacent if one is to the left, right, above, or below. Okay. So call two entries are adjacent if one is okay. That's fine. Note the definition implies that an entry can be adjacent to at most four other entries. Okay, and that the adjacency is symmetric. That's true. Okay. Define a path from entry E0 to E1 to be a sequence of adjacent entries. Okay, starting from E0 to E1 was okay. Fine. Define the region. Blah blah blah. What exactly? Okay. Implement a routine that takes an m by n Boolean array together with an entry point x, y, and flips the color of the region associated with x and y. All right, let's see what exactly that means, because I am not quite sure.
Yeah, it was a bit confusing reading the question because like the description before it like made no, I couldn't find a relation between what they're trying to say and the question.
Yeah,
It's like,
no,
what was that?
I'm going to tell you right now, it's impossible. Like, they have so many mathematical shit, I'm going to tell you, I don't know even understand it. So let's,
Yeah.
but I have some vague idea they're trying to define, like, entries between each other. So then, so that's like, I don't understand it, let's look at the examples.
Yeah, the example is like, made a lot more sense.
Okay, yeah, so it's like being able to first understand, hey, like, this is too hard for me right now. Let me go ahead and try to understand it first. It's that recognition. So colors of square associated with the first square marked in a X in A have been recolored to yield the coloring in B. The same process yields the coloring in C. Okay, what the fuck does that mean? So
okay, so yeah,
no,
I can try
I'm
and
saying
explain.
how we will do it,
Okay.
and how I'm thinking about it, and then maybe that'll compare to what you're doing.
Okay.
Because you said that you spent a lot of time on the idea, right?
Yeah. Well, more idea debugging, more time debugging than the actual idea.
Okay.
But yeah.
Okay, so all the colors are squared on the first square marked with an X and A. Okay. So you have all the squares here marked with an X and A, and then you basically bled that out. Yeah, that's basically okay. I see. So any of the squares that are adjacent to this entry here, and then you take adjacent to that, adjacent to that, adjacent to that, da da da. It's like paint. It's like the paint fill tool.
Yeah.
There you go. See, like it's like once I understand that, then it's like, oh yeah, now that makes sense. And then it goes from A to B, right? And then from B to C, the way they did it is just a fill tool with a white paint. Okay, that's fine. See, like the moment I did that, it's like I instantly understand the problem. You see,
Okay.
like I boiled it down to just a very simple like 5-year-old shit that people can understand. I didn't know those fucking math things. Okay, next thing. So that brings us to your thing here. So you waste a lot of time trying to explain the same thing over and over again and trying to repeat yourself. I think I'm going to listen to this as well. I've listened to this in the video. So it took you 10 minutes to finish the pseudocode. Okay. So let's actually look at what your pseudocode is before we approach it. So implement a routine that takes an okay, blah blah blah, every index, blah blah. So BFS can DFS solve it, yes. You keep track of the original XY color because output is null, so we have to do it in place, yes. Explore adjacent vertices and explore adjacent vertices to neighbors until we reach a different color, yep. Okay, I understand where your pseudocode right now is a little bit verbose.
Okay. Yeah.
This explanation right here. You could have just said you could have made this a lot more simple. Is that take a entry point and then look at all the squares that are adjacent to it that are of the same color. And if they are of the same color, fill it in. Fill it in to be the the different color or some shit,
Yeah.
Do you see how simply I said that? And then you instantly understood it?
Yeah.
You need to make it that simple.
Yeah, I need to be more succinct. Yeah.
Exactly. I guarantee you anyone listening to this stream already understands exactly what I'm talking about. And I didn't have to read the fucking math. So
yeah.
That's so you see that's where the simplicity comes from. And it's like the moment you say that, everything should fall into place. So after that, like, okay, now that you understand that, then it should form this. So let's actually look at the replay and let's see what exactly you did. Because the thing is that when I look at let me double check this one more time, because you said you struggled with this debugging it.
Which one?
Okay, so
implementing it?
Yeah, you said okay. Yeah, so you said you had to struggle to debugging it, right?
Yeah, because I didn't catch that typo, which caused a lot of errors, and then I tried a lot of workarounds. Like, I diagnosed the problem wrong, and kept trying workarounds. But then in the end, I didn't really solve it. I solved it in the end, but I got rid of that error, the original problem. I worked around the original problem I had. And so I basically just worked around the original problem I had, but would have been a lot easier to just fix the original problem I had. It was just like a simple typo. in my opinion.
Okay. And so let's see where this typo comes from. Let me see. Yeah, actually, let me go ahead and just watch the replay because I get the feeling that, yeah, that is basically just you not understanding your own thing. So let me pull it up.
Okay,
Where is
yeah.
the downloads? Is it this one?
Okay. So the question is implement a routine that takes an n times
Oh yeah,
n
there's gonna be a lot of
array
coughing in
together
that
with
video,
entry
so.
x, y, and
There's only a few
flips the
points I'm
color of
actually
that
really interested in.
region is reachable
Wait, actually, let
from.
me open this up with VLC. Hold up.
Yeah, for sure.
Okay. So the question is implement a routine that takes an n times n Boolean array together with an entry x, y, and flips the
Yeah,
color of
I don't
that.
know why OBS. If you're talking about the video output, I don't know why it's kind of chopped up like that.
Whatever, it's fine. I can still see
The indices of my Boolean array.
Okay, let me.
What does it mean by flipping the color theta with x, y? Let's look at the example. Let's type out. Look at the example. The color of all squares is that. Let me double make sure. Recolor to yield the color in A. Okay, that seems like it is it. So, for example, let's make it a Boolean array. Okay, I mean Boolean bit binary. Just make it a bit easier instead of having true and false. So yeah. 1, 1. So, and if we are given the indices 0, 0, then we would flip every index reachable from 0, 0 that also has a value 0. So it would end up being 1, 1, 1, 1, 1, 1, 1, 1, 1. So this is actually
That's fine.
hopefully.
The first 2 minutes trying to understand the problem. That's fine. I spent about that much time. I have no problem with what you did here. It's just you reading. So let's see. Look your next notes. You liked how you consider multiple different problems and solutions to the approach. Okay, I'm gonna say that's pretty much fine. I don't think I need to look at that. And then the pseudo code. So let's see why.
BFS is iterative, a little bit simpler, in my opinion, not simpler, at least a little bit more comfortable with implementing BFS rather than DFS. Though DFS can be simpler in terms of recursion, I do feel like I like seeing it's easier to debug if it's not recursive. Recursion DFS is what I mean to say. So let's write out the steps for performing BFS on this. But first, let me write out the original actual problem first, and explore adjacent vertices to those neighbors of x, y until no more, and repeat until we reach vertex with
Okay, I see. The thing is that
different color.
You are.
When we visit a.
Okay, I see. So you're not thinking about this recursively just yet.
Oh yeah, I mean I never thought of it recursively before, sort of. I mean I'm not too sure.
Okay, so the thing is that I get you have a top level idea here, but the thing is that you need to be able to I guess adapt it a little bit more to how you plan on implementing it. But so far, I mean you have the top level idea. I think that's fine.
Vertex, then.
Yeah, I feel like with the majority of
the
majority of graph problems that I've been solving in EPI, like I had the high level description right. It's just putting that into code is a little bit difficult sometimes.
Yeah. So it's like you have the high level idea. That's fine. So let's see what your pseudocode is. Yeah. So you have while Q is not empty, current x is equal to pop element from Q. Sure. If current y and current x are valid indices. Okay, valid indices by color. You be a little bit more specific about this one. Image at index cur x and cur y is. Oh, okay. Valid index is by bounds or by color. That's the thing you need to specify.
Valid index as in boundaries, like it's within 0 and the length of our array.
I get what you mean. Yeah. Oh, but it's like it's helpful to kind of specify that because validity in this context you have two things, right? One is being out of bounds in the graph. The second one is the color. So I mean, I guess this one here implicitly implies that. I guess and relatively it's small, but just be aware of it.
Okay, yeah.
Okay, so then it's fine. Within boundaries of our array, yeah, you fix that. And so now flip it and then add cur x or y. Yeah, that's fine. And then you take adjacent base q. Yeah, this is fine. So let me see. It doesn't seem like there's anything.
A visited set, a net set that will contain all visited nodes.
Okay, I see. So first things first is that the base structure. You should start with the base structure of the BFS first. So you kind of missing this out is kind of a little bit of red flag. So this should have come first.
the skeleton for creating BFS, right?
Yeah, you literally said you're gonna lead off with
Yeah.
BFS, so you should be able to come up with a BFS structure to begin with, and then fill it, and then add in the things that will help you solve the problem.
Yeah.
So that's.
I feel like a lot of the time when creating the pseudocode, I'm not sure if this is like good or bad, but usually I have the high level description, right? But when I'm doing the pseudocode, I feel like sometimes I'm saying it as I go, but I don't know if that's good or bad. Maybe I should like give them like tell them before what I'm doing beforehand and then going to it, but they already have the high level description. But I do a little, so I'm not too sure.
So you have the high level description. I think anyone understands that. That's fine. And then I think you're fine here, actually. The only thing that I'm concerned about is that you need to start off with the structure of the BFS. I would say if you're trying to come up with it as you go, there are two things. If it's a core structural issue, that's a problem. Like versus this is a core structural issue because it's just you're talking about doing a BFS, which you should have been well prepared for. If it's like, oh yeah, like this is my idea, but I find that I'm having some bugs, then okay, we can that's okay to like because you're not gonna be able to get it right the first time, right?
Yeah.
But you have a core structural issue with the BFS, so that's.
And while I was doing the pseudocode, I felt like I had the core structure of the BFS in my brain, but while I'm trying to write it out, I'm trying to modify it as I go to fit the question, and I think that trips me up.
Yeah, don't modify it while you go. You have an idea, commit to it, and then do the next step.
Yeah.
It's a similar derivative to the problem that you had like last week, where you basically try to optimize while you did the problem. No, you have an idea, stick with it. You have an order to it. There's logic to it, right? You come up with a skeleton. You say you're gonna do BFS. Come up with a skeleton for BFS because that's course basic bread and butter shit, and then you can massage it. So don't do two things at once.
Yeah, I have that stupid habit, unfortunately.
Don't massage it while you're doing it. Okay, so that explains a lot of like why it took you like a lot of time to do this one, because the graph problems should be like fluid. So okay, so then this is you testing it.
Now one at the key.
I'm fine with that.
I feel like my debugging phase is really bad. Like, at some point, I think I just try random things, or like, well, not random things, but like ideas that I've seen in other problems, that might fix it, sort of thing.
All right, so let me ask, well, first of all, I'm looking at this. So you seem to type it up pretty quickly, actually, and so my question now is, all right, so let me see if I can find the bug actually. That's fine. Y and XY not visit. That's fine. Append cur visit add cur x and y, yes, and then you're gonna add q append. Yeah, that's fine, right?
It was a typo error.
Let me see if I can find it, but I don't. Yeah, and x and y not visited. There we go.
It took me so long to figure out.
Okay.
I was so cheese.
So anyway, so the way to fix this is that if you're trying random fucking shit, that's a very bad sign, right? So the next thing to do is if you run this problem, and let's say if this interviewer says, hey, you have a bug, chances are something small like this, hey, you might want to look at their condition, they'll probably tell you it, but let's say the interviewer is mean that day and doesn't want to, right? Then what you need to do is compare your idea to what you got here, right? In this case, if cur x and y are valid indices within the boundaries of our image and has not been visited yet. So literally, it's a statement here. It's a grammatical nitpick. It's like and has not been visited yet. In theory, your brain should understand. You should understand cur x and cur y. That's what it's referring to, right?
Yeah.
But it's like I prefer to be a little bit more verbose just because I like using simple language. But this is where like compound sentences kind of kill you. It's a small thing, but it kind of ended up doing this here. So what I'm going to tell you to do, instead of like trying to like come with simple grammar and whatever shit because it's too hard to change the way you talk or whatever. Instead, when you come up with this and something doesn't work right, compare it to your idea. Compare it to like the plan that you laid out first, because you spent time thinking about this. You spent time modifying it, and you tested it, so you know this is good. The only thing left is that's the first step you should compare to. So.
Okay, yeah.
So like you did all this planning, just stick to the plan. Unless like the plan is like you check the plan and the plan's okay and it still sucked, that means that the plan was probably wrong. It's like going in order of like as we build a pyramid, right? It's like we have a strong base and then we build up. You know, you don't. And then if something like fucks up at the top, you don't fucking like jump around and then try to randomly stack shit on top of it. No. You look back at the base and it's like, okay, what part below me kind of fucked up?
Okay, yeah.
It's like building a pyramid, right?
Mm-hmm.
And I guarantee you, if you spent like 3-5 minutes looking at your plan and comparing it to the code and making sure you stuck to the plan, you would have found the bug.
Yeah, probably. Yeah.
So I'm saying here, like, this is you, bad habits coming up again. Don't fucking do this.
Yeah.
So, alright, that's fine. So we identified where your issues were. Mostly it's just like you trying to do two things at once, and then you just kind of like floundering after and panicking after you find you have a bug.
Yeah, right. Even after testing an idea, yeah.
All right, so it's just you panicking. That's it. Okay, let's go to the next one. Another problem that you felt like demonstrated that you weren't able to translate the idea to code, because I think you actually did. It's just that one little thing of doing two things at once. But it seems like once you had the idea down, you were able to do the code for it very quickly. So
yeah. For the second question, I mean, it was again the implementation that sucked ass.
Okay, so which row am I looking
at? 36. Yeah, 36.
Okay, so this problem is transform one string to another. So let's bring up the original problem again. Okay, so you weren't able to solve. Idea was simple, but the execution was bad. Okay, let's actually bring up the original problem.
Yeah, for sure.
Let's see. What page in the book is this?
It should be like the 7th question.
Yep, got it.
I think
366. Is this the one you recorded?
Yeah, that should be the second one I recorded. Yeah.
Okay.
I hope I uploaded the right one.
Okay, that's fine. Let's S and T be strings and D a dictionary. Set a set of strings. Define S to produce T if there exists a sequence of strings from the dictionary P such that the first string is S, the last string is T, and adjacent strings have the same length and differ in every character. Fuck! I hate reading. The sequence P is called a production. For example, the dictionary is bat, caught, dog. Okay, so it's basically saying that the dictionary here is a set of strings where one element differs from the next element by the next string by one. It says the strings have to be the same string that differ by in exactly one character, but okay, but this dictionary is not that. So
no, you can go. Yeah.
Caught, dog. So okay, so then cat, caught, dog. Okay, all these are delta 1. Okay, so you want the production sequence. So given a dictionary and two strings, write a program to determine if S produces T. Okay, assume that all characters are lowest alphabets. If S does produce T, then output at length of a source production sequence. Okay, so basically, you want to find from like cat to dog if there are a bunch of strings in the dictionary that you can take out and produce a production sequence in order to get from one string to another. That's basically what the question's asking in my mind.
Yeah, that's basically it, yeah.
Yeah, like, see, like, well, even I'll tell you this, like, even fucking, like, this fucking math bullshit, this is why I never pursued a math major or any kind of logic. I can't fucking read this much. So, that's why, like, I always say, like, do things simple, because if you do things simple, then no one can fucking argue. So let's see what you did here. So, okay. Well, then we'll solve vertices S and T, words and D. Edges will exist between two nodes if two nodes words differ by one character. Reachability, yes. If T is reachable from S, yes. Okay, that's fine. So you use BFS, all right, because you want the length of production sequence. That's fine, perfect. So then now you want to build. So you're deciding to build the graph, right? That's fine. Nodes are element in D. Edges only exist if two nodes differ by one character. Convert D list. Okay, sure. D is your dictionary. Loop over every. This is too much like code.
Okay, yeah.
Remember, we want to keep it pseudo codey. We don't want it to look too much like code. We want to get the high level idea. So in this case, what you're doing is just basically looping over every word in dictionary, over and looping over all the subsequent all the
Yeah.
subsequent words.
Yeah, I didn't know how to describe it too well in pseudocode. Like, I want to traverse one, like, what for every character, I want to traverse every other character. I mean, for every word, I want to traverse
or
every
just
other
like
word.
try every possible pairing of words in the dictionary.
Okay.
The trick here
That's
is
a good idea.
explain like I'm 5. If I'm a fucking 5-year-old, how are you gonna explain it to me?
Yeah.
I've already said that before. Explain like I'm 5.
That's a good idea. Yeah.
Yeah, I'm gonna compare every single word in the dictionary to every other word in the dictionary, and of course you know what that looks like. So I don't need to say that. I'll find out if they differ between a character, create an edge between the two nodes. Okay, that's fine. I like this is like hiding away the implication of the graph, but that's fine. Iterate over 2 strings. Although I feel like there is a shouldn't there be like a delta of like some delta function in Python? Because in theory, like you should just be able to XOR the what's it called, the strings, and then if the strings and if there is a character in there that's not 0, then yeah, it's like you can use bitwise stuff for this actually.
I mean, yeah, probably. I'm just not too familiar with bits, so I didn't really think of that idea
That's fine. Even
first.
if you didn't do it, then there's probably like some diff thing. So I would say building. So but already right now your runtime is n squared.
Yeah.
So,
actually, I think it's a bit higher.
Yeah, because you also have to multiply by the average length of words that you got going as well.
Yeah.
But all right, BFS pop node. Okay, so if the for visited set while queue not empty, pop node from queue, which means that you have to initialize queue node starting S.
Yeah,
fine. So
this was just a code BFS.
So your code, your pseudocode is fine. It's just that it's a it's not as efficient because you have the n squared thing going on. So the next so the next question you should be asking yourself is
like how to optimize it, sort of thing.
Yes, but more specifically,
now how to make it faster. You mean?
Yeah, but along your time complexity and like decrease the time complexity.
Oh yeah, the time complexity is really really ass.
What? The thing is that you need to ask these questions yourself.
Oh yeah. I mean, I realized while like I was writing through code, it's really ass. I just didn't like say it or anything because I felt like I'll improve upon it later on. So time efficiency doesn't really matter for the first solution.
Right, but I'm prompting you literally to say that, so that way you understand what your next thought should be and what your next action should be. So okay, that's fine. So right now, I would say aside from the word thing, your pseudocode is fine. I think it conveys perfectly the idea. So you're saying that the book says that there's probably a faster way to do this.
The book says, yeah, the book has a faster way to solution.
All right, cool. So let's actually walk. So let's walk through it. Did you say the logic of how and why?
How and why it?
Yeah, like what the steps the book take? Why didn't you get the same answer?
So basically, the book created this like it didn't build the graph. It built a graph as we go, sort of thing. Okay. I built the entire graph beforehand. So that created a lot of inefficiencies. The build graph was essentially they did it as we go. I did it beforehand, and that caused a lot of errors. I mean, a lot of runtime worse.
Okay, yeah. So now that's the trick. So instead maybe try being lazy with the approach instead, like lazy loading and shit.
Yeah.
So that's gonna be a tool in your toolkit. That's the thing that you need to write. You need to write down the main idea behind it. So it's like, so why don't you, instead of front loading the work, do it as you go? It's a powerful tool.
Yeah.
We use it all the time, not just in graphs, but it's just like any kind of tool we use. If we want to save space, that's kind of how we do it. So
yeah.
So this is that's what you need to write in your diary, because once you say, hey, yeah, why don't I just do this like as I go, then you should be able to come up with that. But we'll see. Anyway, so you said you were unable to find. You're bad at debugging and unable to find the bug. Okay, is this the one you recorded?
Yeah. This is the one I recorded.
Right, let's see why you weren't able to get it right. Because again, the debugging, you should have just like tried to look at the plan. So let's see.
Yeah, I should have tried looking at the plan. Like I thought I knew it in my head, but like, and then after I thought I knew it in my head, but then when I ran into error, I was like, you know what? Let's change up like maybe a +1 0 there. Add a +1, remove a +1.
Let me
And
try random bullshit again.
yeah.
It doesn't work.
Yeah, it
You
doesn't.
don't luck into it. Everything has to be methodic. Everything has to be, like ordered, and there's a logic to it. So.
Yeah. I mean, I think I identified correctly where where my initial problem was. It's just that I wasn't clever enough in the moment to think of a proper way of how to do it. It was a differ by one character function. Like I didn't know how to. I didn't know any function. I thought the initial implementation I had of it was correct, but it doesn't seem like it was. And then I couldn't come up with the manual implementation that I knew was correct on top of my head.
So you didn't know how to iterate through 2 strings and just check to see if there are more than one character different.
Yeah, that came with not checking the design because I wrote it down in my design, but I didn't think of it while I was writing the code. I was like, huh.
Okay.
Because I came with an optimization that I thought was actually correct, but it turned out it wasn't, and then I forgot about the initial design I had.
Yeah. So in other words, the lesson today is don't do shit in your head. You wrote it down for a reason.
Yeah. Yeah. I even debugged it a little bit too. Like my optimized solution, and I thought it was correct. But, trash. Didn't get it too well.
Yeah, you didn't do well because you completely ignored your plan. You do all this planning, and then you fucking throw it away, and it's just like, what's the point?
Yeah.
It's like I'll give you an interesting story. It's so basically in the medicine field, right? And I'm going to explain where this tangent goes. It's basically that doctors and for patients in the ER, doctors and a team of doctors and nurses have to perform basically on average 187 steps in order to save a human's life or like to take care of them, right?
Yeah.
And if any single one of those 187 steps, basically like fucks up, like say someone say someone forgets to put the tube in or whatever, or like someone forgets to wash their hands or some shit, then the tubes get infected. That can fuck the patient over and they die, right? All it takes is one out of those 187 steps. And so basically, what happened was that this doctor basically went into the operating room and said, "Hey, you know what? Let's have a checklist. Let's make sure that at every single step there are sub-steps that we make sure everyone follows." So in other words, if you think of something as simple as like, "Hey, the doctor should probably put on a mask, wash his hands, and put on a hair net and whatever." Like what they found was that even though these doctors were like highly sophisticated and these steps were like no-brainers, almost like 30-40% of them forgot at least one of the steps. And these are simple bullshit, it's like no-brainers, right? So this is where now hospitals basically have a checklist, and the checklist basically reduced the amount of patients dying from I basically saved the hospital at least $2 million a week or a day. I don't know. Yeah. It's like some massive amount, literally just by putting in a checklist that pilots had, that fucking movers do. It's things that are like in general like blue collar shit that are plainly obvious to them, but are not obvious to people in medicine. And you don't have to fucking spend a shit ton of money on antibiotics and shit. All you do is just have a checklist, make sure everyone follows it, and you save yourself a lot of grief. It's the exact same idea here. You have a plan, you have a checklist, and then you decide to execute on it. Something went wrong. Look back at your fucking plan. Because software engineering arguably is pretty complicated. Maybe not as complicated as medicine, but it's still complicated enough that you actually can benefit from just simply having a fucking checklist. I'll send the article later if you want. But it was in the New Yorker, but it was super fascinating actually.
Okay, yeah, that sounds interesting.
Yeah. So if it can save fucking lives in a hospital room, why can't it help you solve code?
Yeah.
So anyway, let's see how you debug. So it's so different from one character. Yeah, this is kind of the thing. Different from one character, you can just loop through the fucking 2 words. I don't know why you're doing some crazy bullshit like this.
Yeah.
Just start simple.
I think. Yeah, go.
I was gonna say, just start simple. Start with something that is brain dead, and you know what to do.
Yeah.
And then also
I thought cause okay, I was thinking I might make mistakes in that those lines of code. Let me see if I can find a built-in function that automatically does what I do, so I know there's less chance of bugs.
Are you gonna fuck up looping over 2 words?
No, I mean low chance. But I didn't want to go over a typo bug or something again.
Yeah, so you basically the last problem you did fucked you up because you didn't check your plan and then you decided to misattribute to something else.
Yeah.
It's basically literally,
Or
it's like we're gonna make mistakes, right? The question is how do we deal with them? And in this
yeah.
case, like if you just had you stuck to the plan, then you would have been fine. So anyway, in this case, let's think about this logically. If a programmer in front of me cannot compare two words, I'm probably gonna fail them in general. So and in general, you probably already can do that too. You can actually you can actually compare two words. You should at least. Like I hope you can.
Yeah.
Yeah,
I
it's like
can.
anyone
Yeah.
with a fucking first year Java. There's no reason to doubt that.
Yeah.
Now, if
I
you
was
ask me to build a
yeah.
build system that can compile our entire 2 million line code base, I might have some doubts. But looping through two strings, that's fucking baby shit.
Yeah.
So it's like if you're gonna lose your confidence, at least lose it in something complex that's not obvious.
True.
So it's like okay, yeah. So you already know what I'm gonna do. Just don't do shit in your head. Basically, keep things as simple as possible. You can always revise it and do it faster, better later. But it's important that it's done. Done is better than perfect.
Yeah, for sure.
Of course, we try to aim for perfect here, but if we have it done and it works, then we know there's something in there that works, and we can improve upon it.
Yeah.
So that's basically it from me for these two problems. Just boil it down to you sticking to the plan. And
For sure.
That's it. Other than that, I don't. Let me see what else you have in your diary because I don't want.
Yeah.
I want to make sure I didn't miss anything else.
Yeah. I do have problems with implementing the idea to. Yeah, I already said this. Yeah.
Yeah.
I have the trouble implementing the idea even after creating the high level
Okay.
description.
Which one did you feel like you had the most struggle with?
For that specific problem, not unable to implement idea. I think it was row 35, making wide connections. I knew what type of problem it was. I knew how the way to solve it, high level, but actually implementing it was a bit awkward.
Okay.
Sort of thing.
All
And it took a unnecessary amount of time, is what I'm saying.
Okay. Let's see. Let's see. Let's look at the problem first. So 364. So consider making a collection of electrical pins, blah blah blah. Each pair of pins, there may or may not be a wire joining them. Okay. Design an algorithm that takes a set of pins and a set of wires connecting pairs of pins and determines if it is possible to place some pins on the left-hand side of a PCB and the remainder on the right-hand side such that each wire is between left and right halves. The fuck does it mean left and right halves? Return such a division if one exists. For example, the light vertices and dark vertices are such... Okay. So you want to be able to make sure that... Oh, I see. So is that no matter what path you take, it's going to alternate between light, dark, light, dark, light, dark. Okay.
That's a good explanation. I did not think of it like that.
I literally just... Yeah. All I did was like read the problem. I said, I have no idea what the fuck you're talking about. And then I said divide in half. Okay, this looks like it... light, dark, light, dark, light, dark. I just traversed through the graph. That's it.
Yeah.
I would argue I'm probably dumber than 90% of the people like watching this or even in my Discord server. I am fucking dumb. The only thing I got going for me is like a systematic way of evaluating problems.
Okay. That is a very good system.
Yeah.
Yes.
And I guarantee you, like, you don't need to be brilliant. You just need to make it simple and efficient.
Yeah.
So anyway, so now that I have that, let's see. So you took 15 minutes. So let's see how you did it. Color each node red. Sorry, you did it blue. Deciding if it is possible to partition the vertices such that there are two independent sets that edges only go from one set to the other set. Okay. I see.
So in this problem though, the pseudo code is a little bit off. I had to look up several things on coloring beforehand, after, like during the problem, because I had the idea, but I was like, how do they like do this sort of thing like with Wikipedia? So I don't think the pseudocode really reflects what I was thinking.
Okay,
at
so
this point,
you decided to just like look up some random like bipartite code on Wikipedia and implement it.
Well, just the two coloring method, yeah, but yeah.
Okay, I mean, like if you're trying to, well, that's why you have trouble like doing the code because you don't really understand it. You copied it from somewhere and like, oh, I see what it is, and then you tried actually writing it. It's like, oh fuck, I don't understand where it's coming from or why I'm doing this.
Yeah.
It's very simple. It's a very simple explanation. It's like, The way I would do this is like I don't even remember how to fucking test for that. I might look it up for Wikipedia and try it out, but like if I was doing this problem, I would have just done a breadth first search and then labeled each node.
Yeah. Yeah, like that was like my high level description essentially. It's just I didn't know how to put that into pseudocode. Unfortunately.
Well, that's the thing. You need to have a very simple idea, and you need to state it very simply.
Yeah.
So notice how I just said breadth first search, and then just alternate. And so with the way I would write, the way you would write the pseudocode is just to start with the breadth first search, and then look at the pass, add that node to the queue, and then make sure that and only add nodes. You know, if they're look at the adjacent nodes, and if the adjacent nodes have the same color, then return false.
Yeah, that was like my general idea too. It's just if you look at the pseudocode, is the if else part I didn't know how to implement.
Okay.
Like everything else I got like on the dot is just how do I, make sure, how do I check colors and all that. But yeah.
Okay, well that's the thing. That's where you actually have to start like trying the problem out after. It's like
yeah.
Hey, this is clear. Then just say, hey, okay, let me just try it with this node here. Then just like get label it 1, 2, 3, 4, 5, 6, 7, 8, whatever, and then just like walk through it. That's the next part.
Okay, yeah.
Yeah, I was like, you have an idea of where it's gonna go, then just try out the fucking example. And I think this is the part of where you try doing it and you're getting ahead again.
Yeah.
Because it's like, hey, yeah, I have an idea. I'm pretty sure it works. I just don't know what exactly the algorithm for it is, and they'll be like, okay, well then just try it out, right? That's perfectly logical. I don't think any interviewer is going to blame me for that.
Okay. Like try it out as in write the pseudocode out for it and then see what happens, or like write the actual code for it and test it.
No, as
or
in just look at an example, like an example graph, and then just like do a stack trace where you have variables, right? And then you assign things to those variables, and then you say, hey, at this point in time, I have a queue that has these variables in it. I'm going to pop one out, and then draw that out, draw what it looks like popping out of the queue, and then do what's supposed to happen, right? It's basically saying what are the variables I'm doing what the variables look like at each step.
Okay, yeah, that's true, yeah.
It's literally just walk through the problem. It's and this is also how you can bulletproof and test your code. Is that just throw some examples at it and make sure that you cover every single branch of logic.
Yeah, for sure.
Okay. So, you understand the idea. Don't do shit in your head. Explain like I'm 5, and make sure you stick with the plan. That's pretty much.
Yeah.
That's pretty much all of this boils down to. I mean, it's not terribly difficult. It's that you just need to be able to discipline yourself and be able to do it and catch yourself when you're fucking up.
Yeah. So. Sticking to the plan. If I do mess up something in the code, make sure I actually relook at the plan that I tested and designed.
Yep.
Yeah. Okay. No early premature optimizations.
Mm-hmm. Yeah. So it seems like you're spending a lot of time on this, which is fine. I'd rather you really, really hammer in and make sure you don't make the same mistake. That's all it is. It's just about making sure you identify your mistakes and never make them again.
Yeah.
So I don't care how long it takes you to do that. Just at the beginning, if you front load the effort, the latter problems are gonna be so much easier.
Okay. Yeah.
So that's the practice diary. Now, homework-wise, I think you're pretty much almost done with the graph problems, actually.
I already finished the graph problems. I'm on linked list right now. I just haven't really done much of the linked list today.
Okay, because I know we talked like last time about like recursion, and you said like you felt like shit about them, and now you feel okay about it.
Yeah, I'm still okay. I think there's still gonna be a lot of problems I don't know how to solve. Okay. But I think I'm a lot more comfortable with recursion than I was previously.
Okay, do you want to try? You should look at the problem sheet that we did, and the problems that we talked about, and try to redo those.
Yeah, like redo in the practice diary those questions.
Yeah, redo the problems that we did last week.
Okay.
And then after that, I would want you to. And then after that, I think you can start on arrays and strings. You're actually going through this shit pretty fast. What the fuck? So, all right.
Yeah. I mean, I think in the upcoming few days, my progress will slow a lot now that work and classes are catching up and all that.
That's fine. I fully expect that. But at least if at this rate, you're doing what I think you're doing, and it looks like it from the replay analysis. I think you should be okay with recursion. But yeah. So the next thing you do is to do like arrays and strings. So chapter 6 and 7.
Yeah. Well, after finishing linked list and stacks and queues, right?
Yeah. Linked list, stack, queue, and then array and string.
Yeah,
So
yeah,
just
okay,
do
yeah.
your homework. Anyway, I think that's it from me. I guess next week for coach, or not next week, but when we do coaching later on this week, we'll be trying. I'll be poking at your recursion, so make sure that you actually understand it. So.
Okay, yeah, for sure. So I went over like the document that Google sent me, right?
Yeah.
And then I'm getting really nervous because it's four rounds of interviewing and one behavioral, three technical, and they're asking me 1 to 3 questions per technical, and that's getting me like, do you think I can? I don't like because if they ask me 3 questions and the technicals are around 45 minutes, that's like on average maybe 15 minutes question. I feel like I'm taking too long to solve them, like because currently I'm solving questions within like 30 minutes
Don't
and
worry
like
about
20
the
to 30
time.
minutes. Isn't
Don't worry
that?
about the time. Worry about making sure you have a bulletproof approach because I guarantee you they want to see you solve 2 questions really, really well, logically, cleanly, then watch you like come up with an answer for 3 really, really sloppily.
Okay, okay, okay.
There's no like one of them can be behavioral and then 2 of them can be, coding. That's the thing. So keep
No, 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 no. Like, there's one interview dedicated to behavioral, and then the other 3 interviews are up to 3 questions of only technical.
Yeah. Because keep in mind, some of those might also be follow-ups. Like, okay, now that you've written this code, what would you do to implement it? With concurrency and whatever shit, like improve it.
Okay,
So
yeah,
that's not you gotta keep that in mind. So don't worry about the fucking time. Again, it's about having a bulletproof approach that is efficient.
yeah, for sure.
And believe me, any engineer will
Yeah.
appreciate that.
Let's say that again. The interviews will appreciate the
If you
bulletproof
have a
approach.
bulletproof, efficient
Yeah.
approach, any interviewer will appreciate that.
Yeah. Okay. Yeah, for sure.
Right. You got anything else?
They also said the Google was like, oh yeah, it'd be nice to know OS concepts like operating system. Do you think I really need to know that? Because I am very like shit at OS stuff.
I mean, focus on this for now. I think OS would be more like, oh yeah, like they might quiz you on the first 5 minutes, but it's because you should have just studied it in school, so you should know it.
Okay.
Unfortunately, I am pretty like I've forgot a lot of the OS stuff myself. I mean, I do remember some of the stuff, but unfortunately, I wouldn't be a good coach for that. All I can say is just study up, bro.
Yeah, for sure. I'll probably just read the OS, the concurrency problem and EPI, and just go with that.
I guess I actually have no idea. Like I've never been asked an OS question, and I don't think any of my clients have either. So I unfortunately can't give you any advice to that other than
It's
just pretty
okay.
sure.
I'm hoping they don't ask it. I think it's just like them to like mess with you, sort of thing, or unless you're dealing with a specific OS job or whatever.
Okay. Yeah. I mean, you understand. So.
So yeah. All right. Yeah, I think that's it for me.
All right. Sounds good. Then I'll let you go.
All right. Cheers.
All right. See you later.
Yeah.
All right. Cool. That was it. Anyway, is there any questions from the crowd? I'm going once, going twice. All right. What do you think about this client so far? I mean, he's putting in the effort, and I'm seeing a lot of results so far. I think there's a pretty clear progress, and I think that oh yeah, Russ is in the chat. So for me, I would say that I think I'm making a lot more progress, mostly because I'm hammering on the practice diary a lot earlier. I think that's a problem. You mentioned this actually, Russell, in the feedback session, where it'd be a lot better if I was a little bit more clear on the expectations for the practice diary, and if I would hammer that in. So I think like me nipping in the bud early and really hammering for the past like 5 days on what the practice diary should look like, what problems should be handled, and like how to specifically do it. I think so far it's like it looks good, but I don't want to be too optimistic. It's only been like 5 days, but overall I think this is definitely like some of the fastest improvement that I've seen so far. So if this works, then that means that I'm doing something right here, and that going forward with other clients, I'm probably going to spend the first week or two really hammering the practice diary. So I'm very hopeful, and I would love for this to actually work out. You know, getting a Google offer in 5 weeks from nothing. I mean, you guys saw the first episode. I mean, if Yahoo, I'm not Yahoo, but if YouTube brings it back from private, but yeah, you guys saw the first episode. You saw how bad it was. If we can turn that from going from there to Google in 5 weeks, honestly, that would be a great notch on my belt, man. And like I'm always open to like bigger and bigger challenges and improving my system and how I coach things. So if you worked with me in the past and you're in the crowd, like fucking give me feedback, man. And you can see like I'm actively applying that feedback to everything I'm doing, and you know like and I'm hoping that with time, not only can my hit rate go better and better, then my hit rate will go up, but also my time needed to prepare those clients can go down. That'd be great. Unfortunately, there is a limit to the number of, I would say, the time, because you know, like I have to spend a minimum amount of time with the clients, right, in order for them to improve. It's not like I can say 1 week, boom, you're gonna get instant Google offer. That's almost impossible. That's pretty much impossible. I mean, I could probably get it down to like 6 weeks, but this will prove to me that I can at least do it in 5. It's possible. And so that's kind of like why I'm doing this, and I'm not even sure like if I can do it, but that's why I kind of decided to give him a discount on the coaching, and I made the entire fee contingent on, well, not really in the entire fee, like half of it contingent on the it's a bonus structure contingent on him getting the offer. Actually, fuck, man, I've been pulling like a 13-hour day so far. No, 14 hours now. I woke up at like 8 or some shit. Yeah. So yeah, I'm hoping it works out. Soon we can have an Edwards client group chat internally at G. You know the best thing you can do? If you want to do that, just get into infrastructure at Google. All of you, everyone who's been my client, just get into infrastructure at Google. I guarantee you in like 10, 15 years, you will be like fucking VPs or senior staffs, and you will have like so much fucking power. It won't be funny. It's not gonna, it's literally like, you have all the same ideas, you all think the same across the board, and if you go spread to other companies as well and adopt the exact same thing, you will have such a tight-knit network. It will basically be like a mafia. But it's like, of course, like it fucking scares people, right? But like it's an engineering mafia that maintains the engineering standards of what is good code and what is bad code. And I guarantee you, like if this actually happens, you will never see and hire a bad coder ever again, and they won't cause any damage. It has to start from the top. I mean, this is like kind of like a you can call it a revolution, but honestly, I don't see it like that. If you guys decide to do that, then that's all for you. But for me, I'm just doing this for the fucking lulz. You know, everyone can have like the grandiose plan of like, oh, what this all means, and I mean, I'm showing you it works, right? But that's all I'm doing here. I'm just here to prove a point. I'm just a guy proving that I'm right. Whatever you guys decide to do with it, it's up to you. What happened to the first session video? So apparently there's some fucking a problem with YouTube where they literally made my video private for whatever fucking reason, and I can't figure out why. They just said, oh yeah, your video is spam, and I'm like, I've been doing this for a fucking year. Can I get what the fuck are you talking about? So I don't know, man. Whoever's in the chat and works at Google, please get them to fix this shit. That's all I gotta say. Anyway, I think that's all the questions from the chat. Oh wait, the video went public again. Okay, is the video public again? I think the video is the video public? Fuck. No. Okay, so it's private. Let me make it public again. Okay, the video is public. I just fixed it. or Google fixed it or whatever the hell. Yeah. So Google fixed it. We're good. So y'all, if you want to watch the previous coaching session, you can go to my channel, watch it. It's gonna be live right now. So with that, thank you all for watching me. I guess we'll be having another coaching session this Thursday or Friday. Stick around for that. Thank you for subscribing. If you guys want to keep in touch and know when my next coaching sessions are going to be, you can follow me on my Discord or Twitter or subscribe to my YouTube channel. Link is in the description down below. Other than that, I'll see y'all later. Oh yeah, and if you guys want coaching yourself, you can book me for coaching at echantech.com. And I'll see y'all later. Thank you all for joining me.